just to like
Today's not so bad. It's important, but it's not bad homework compared to some of the stuff we ended in chapter 3. But what we're going to talk about in this first section is extreme values, how to find extreme values of your function, and then as we go through this chapter, we're going to get into more exciting stuff like story problems, related rates, like a ladder is falling down the side of the building. Like, at what rate is the bottom of the ladder moving? Isn't that exciting? Um, an important issue in real world problems. Maximizing stuff, minimizing stuff, really, really kind of useful idea outside of math class. And so that's what this stuff lets us do. All right, so lots of vocab for you. Let f be a function with domain D, then f of c is the, what do you think it is if the value on the domain, if and only if f of x is less than f of c for all x and d? Does that just seem like a foreign language to you?
Yes.
We've talked about maximum and before, right? Absolute maximum, put it in non-math terms, the highest point on your graph, right? So we could write that. The highest point on f of x. And so they're saying if C is the maximum if f of c is bigger than all the other values, right? That's what it's saying. I don't know why they don't write f of c first. And so then we can say the absolute minimum, f of c is the absolute minimum on the domain if and only if f of c is less than all the other values on the graph, or f of x is greater than f of c, or the lowest point on your graph. Does every graph have a absolute maximum and absolute minimum? No. And so that's what the extreme value theorem is going to kind of help us. We don't usually say absolute max, absolute min every time. So I have other words for you that mean absolute max, absolute min. What does AKA stand for?
also known as.
Also known as, I don't know if I ever, global max and global min. I don't really ever use that word, but the book does sometimes. Extreme points. Why do you think max and mins are called extrema points? Yeah, like the highest or lows. So we don't. So when you say more than one extreme, you say extrema. So that's some fancy English for you there. So absolute extrema. And then sometimes we just say max or min, right? If I say find the maximum, it's implied that it's the absolute maximum. Okay. So just like everything in calculus, more than one word means the same thing. And so a big part of understanding questions is knowing what you're looking for. So let's look at our friend x squared, right? That's like our favorite function, isn't it? Let's look at some different domains and talk about what the absolute extrema would be for those graphs. So f of x equals x squared. I hope you can graph that pretty much with your eyes closed. Right? Y equals x squared. I kind of missed the zero there, but you know where it's supposed to be. What would the absolute extrema be for this graph?
Infinity.
0 would be a minimum, right? So we could say x equals 0 is the absolute minimum. No, that's not right. The minimum, is it the x coordinate or the y coordinate?
Y coordinate.
So we could say 0 is the absolute minimum, and it occurs at x equals 0. Right? What is the minimum? Where does it occur? It occurs at the x value. It is the y value. Or sometimes you can just give the point. Give the point of the minimum or maximum. You could say the point, 0, 0. Right, so I'm gonna write them both ways. Does this graph have an absolute maximum?
Yes, infinity.
No, infinity is not a number, right? So if it's infinity, we say it does not have an absolute maximum. So no max. So now let's restrict our domain. What if we graph this from just 0 to 2 included? So I would get 0. When I plug in 1, I get 1. When I plug in 2, I get 4. And I would get just this little segment. Yes? Does this graph have a minimum? What is it? Same. Okay. So minimum of 0 at x equals 0. And then over here, I'm just going to put 0, 0. Does this graph have an absolute maximum? What is it?
4.
Max of 4 at the point x equals 2, or you could say that's the point 2, 4.
I don't know why I would want one. That's why I write max. I wrote x.
What if I look from 0 to 2, not including 0? Who did invent calculus?
Isaac Newton.
And?
Descartes.
Wrong. Leibniz.
Jack the Ripper.
Leibniz, right? Leibniz, I don't know how to say it. He actually did more than Newton. Newton's calculations were actually not that great. When we do, he's not, but I'm just saying, it wasn't exact when you got into it. Leibniz, the notation that we use for integration came from him. Other people did way more stuff later using their ideas. There are fathers. Newton gets the credit because Leibniz didn't publish it till later, and Newton accused him of stealing his ideas. What about this graph? Does it have a minimum?
No. Yes.
How many think no?
It does.
Then why are you raising your hand for no? How many think this does not have a minimum? How many think it does have a minimum?
I don't Brad does too.
How many didn't vote?
So did Katie. Katie Hill would think that it has it.
Okay, so what's the minimum value?
Getting smaller and there's infinite numbers in there.
Right, what's the smallest number? Zero's not included, so what's the smallest number?
Really close to 0.
There can be an infinite amount of zeros.
Oh, I think this whole idea of limits again, right?
So yes.
There is no.
Yes, there is. It's right here. I see it on the graph.
It's not, because it's not included, so tell me what's the minimum then? What would you say the number of the minimum is?
Take it too long forever.
Zero not included?
Zero.
Right? So that's why you can't say there's a minimum, because there's not a lowest value. Just like up here, when you say is there a maximum, there's not, because you can't say what is the highest number. It doesn't get there. And although it doesn't include 0, right, there really are infinitely many numbers getting closer to 0. Oh, limits, they never leave us. So we're going to say no minimum.
I have to do a limit thing.
Yes. Did you not do that yesterday's test?
So you can do a central championship this Friday?
Probably not.
Give it a try.
I don't know. I might have a date night with my husband. I told him we could go have a date to the sectional championship, and he said, I was like, yeah.
Your husband said no?
He said, that's what he said.
This is the first time she's ever thought of the central championship.
I came to, like, something here, semi-something. What was the next one you went to after that was here?
2013?
I went to regionals and you lost, so
That was
probably I'm
3
bad
years
luck.
ago.
I went to games this year, but I'm saying I went to regionals and it was cold.
Lucky until it went to cost.
Yeah. No, I came to one you were winning. Maybe. Did you win homecoming? Nope.
That was Sullivan and should have won.
And then I came to another one you lost. Yeah.
That was not. Yeah, no, never mind.
I told you.
Just gonna stick to baseball.
Does this have a maximum? I've kind of already
Yes,
let on that it
2.
does. Because it's included, we can say a max of 4 at x equals 2. Okay, so using what we learned on this one, think about the last one.
Is not.
Because neither endpoint are included, we're never going to get to that highest value or that lowest value. And because we've talked about limits before, you don't fight me on this. That's kind of exciting, right?
Yeah, there's
Normally.
No, I'm saying, like, remember in limits when we talked about, like, did we ever get there and we had a big, like, ordeal about it and I'm just saying. Okay. This leads us to the extreme values theorem, also known as the EVT. On the AP exam, if you said by the EVT, they know what that means. It's common to say EVT. Back in geometry, you spent a lot of time talking about if-then statements. The if part of the statement is super, super important. If the if part isn't true, then the then part isn't true. So let's, before we fill this here, what is the only one of these that has both a maximum and a minimum? What's different about the domain of the second one from all the other domains?
it has brackets.
It is a closed interval, right? All of these would be continuous functions over that, but it's a closed interval. So we can say, if f is continuous, if it's continuous on a closed interval, so those are kind of our two requirements. It has to be a continuous function, it has to be a closed interval from A to B. Then your graph will always have a minimum value and a maximum value. That's the only way that you can guarantee that it will always have one. All right, so the big part of your homework today is you get to say, does it meet the extreme value theorem? And if so, what are the max and min values? And so notice I said it could be the endpoints, but it also could be a point in between. And we're going to talk about how we're going to use calculus over the next couple days of how that's going to help us find it, of a point in between. Maybe you also remember finding local or relative max and mins in the past classes. Do you remember the difference between an absolute max and a relative max? Relative is just a turning point, like a high point in your graph, right? So like this graph, do you agree that graph does not have an absolute max or min, but it does have a local min, and we define that as a turning point, or we define that as the lowest point in this general area of the graph. And this would be a local maximum. So really important, again, vocabulary, that you pay attention to the wording there. Local maximum, different than relative. Nope, not different. Different than extreme maximum, absolute maximum.
Nope, not different.
I know, I said the same thing. I don't think I made this like disappear. And so it says, let C be an interior point of the domain of the function. At C, if f of C is bigger than all the f of x values, that would be a local max value. And notice it says, for all x in some open interval containing C. Or I'm just going to put a high point on your graph. High point slash turning point. And if it is some little interval on your graph, f of C is smaller than all the other values, we can say that's a local min. Probably we use relative max and min more than local max and min, but both of them are acceptable. Okay? So, look at this awesome picture I gave you. I printed these notes for you because I really just drew all your graphs for you. Like they're all hand drawn. See?
What is that's like a snake's tunnel.
Okay, so what I want to do is say what each of these are. Is it a absolute max, an absolute min, a local max, or a local min?
I know what it is.
What is A?
Local, I mean absolute.
Which one do you want to stick with?
Absolute.
Why is it absolute? It is the lowest point on the graph. I wonder if I have this magic here. Oh, that's so
Why
sad.
is the A different than all the other ones?
I don't know. So A is an absolute minimum. You want to go in the order of the picture or the order of the letters?
Why are they?
Picture.
Because I did A and B because they're endpoints, and then I did. I don't even know what I did actually. Does that really bother you?
Ah, no, like, just go in order. Go.
Teaches math.
It's not even like we started A, B, then we did C, A, B, C, D.
I don't know. What would B be?
Absolute math.
No.
So let's look at this graph.
It's not
So
even a turning point. We don't
does
know.
this graph have an absolute maximum?
Yes.
Which one is it?
D.
Because it's
D.
the highest point on it, right? So D is the absolute max. Let's wait on B. B's a little tricky. What about C? It's a relative max. It's a high point in your graph. It's a turning point in your graph. Notice that all the points around it are smaller than it. That's a relative maximum, right? So all of these other points are smaller than it. So C is a relative max. Yes, so local max, relative max.
I actually put max first. I put max.
And
As if it was that.
E would be a relative minimum or local minimum because it's a low point. All the points around it are bigger than it, so it's a local or relative minimum. Peter says yes.
Says I says yes. Do you need a drink?
Okay, you can go drink if you need to. So let's look at B.
Dixon has water.
Maybe it doesn't look so great from my drawing. But, who said over here? It's not even a turning point. How can it be anything, right? It stops here.
But it's going.
Is it, right, is it like smaller than all the other points around it? Is it bigger than all the other points around it?
It's the bottom of a slope, which means it couldn't be a max because it has to go back up to go down.
But
It's below the max.
It is lower than all the points around it.
It's lower than all the points around it, which means we can say it's a relative minimum. I know my graph isn't so great, but it's supposed to be that all these points are bigger than it. So it doesn't matter that there's nothing on the other side. A relative minimum is one that's lower than all the points around it. It just doesn't have anything on this side to show it. So this would be relative min. And even if it continued, we don't care because we're stopping it. We're only looking on the interval from A to B. Okay? Questions about this?
Yes, Brad, you have a swine flu.
Are you looking at the top point?
What was that?
Is it bigger than A or B?
The Dino CPR here.
So you're just looking at C and D, just looking at
Local, you just look right around it, right? So you're just looking basically like at this section of the graph. Like local, this point, let's see, this point is a local minimum, even though that one's lower than it, because if you just look like at that section, it's lower than all the points around it. Does that make
It's like
sense?
slower than the points of this neighborhood.
Yeah, yeah. Just looking at the neighborhood, not the whole city.
I just gave you a green light. Analogy. Thank you.
Okay, let's look at some more. Let's look at some other equations. Oh, look at this.
at least the letters are in the right
Is it supposed to be
order.
so shaky or is it like supposed to be continuous? Like between the max and min, is it supposed to be?
It's supposed to be a smooth curve. Joke face.
Sometimes they have those little things, you know, like spider.
There we go, spider.
Notice that it says identify each x value that is an extreme point. Notice there's no y values listed, so that's why we're not giving the y, like what is the maximum. It just says identify each x value that's an extreme point and tell whether the extreme value theorem applies. What has to be true for the extreme value theorem to apply?
A closed interval.
Continuous and a closed interval. Is this function continuous? Is it on a closed interval? Yes, so we can say EVT applies. If it applies, what do we know? We better be able to give a max value and a min value. So, what is the maximum? What is the minimum? So here's here's my question. When it says find each value that is an extreme point, does that also include local? They're really called local extreme points too. They are. I don't know. I think we're supposed to list them all, but maybe not. Maybe we just want to.
Extreme of it.
Extreme.
Extreme is like the extreme extreme.
Yeah, okay. So just doing maximum. Okay, or just maximum. We'll just do that then. Would A and B, if we did list local extrema points, would A and B count as local extrema points? Because A is lower than the points around it, B is higher than the points around it. That's a nice graph, right? That's supposed to say 0. I don't really know why I wrote that, but is extreme value theorem apply?
But check DBT. Check.
So this isn't so bad, right? Isn't this not so bad? It's not so bad today, I promise. There's 2 more days of it, but
That's what.
the maximum would just be at x equals 4, right? And the minimum would be x equals 0. Did I write x equals on the last one? Or did I just write a0 x? Since it was x1, I guess that's why I did that. Does anyone have a question about that? Is that the only homework I have on here? That's terrible. We need to do one that doesn't apply, right?
The next one doesn't apply.
Oh, okay. Oh man, look at this.
Scared me.
Not
No, we don't
continuous,
need to do
not
anything else.
close, no unity.
Right, it's not continuous and it's not a closed interval, but if either one of those is not true, that means EBT does not apply. I don't even know what that says. But. So if it doesn't apply, that doesn't mean there's not a max or a min. It just means it doesn't guarantee a max or a min. Does that make sense? So it could still have one, it could still have both. It might have neither, but it just means it's not guaranteed. So on this one, does it have a max or a min? That is the lowest point on this graph. But x equals 2?
Just like same. It's like there's a point in the middle and that one's able to close.
Well, it says give the x value where it occurs, right? I just think it's better to say x equals 2, because if you just write min equals 2, when I read that, that to me is applying that the y value is 2. You see what I'm saying? You could say the point, on this one you could say the point, the minimum occurs at the point 2, 1, since it's actually labeled. If there's no y value labeled, then that's why you can't give the y value. And some of these that you'll see on your homework don't have y values, and so that's why you can't give it. Alright? So I did give you time to work today, so